Solving systems of linear inequalities. Our objective is to graph and solve systems of linear inequalities in two variables. Who uses this? The owner of a surf shop can use systems of linear inequalities to determine how many surfboards and wakeboards need to be sold to make a certain profit. Let's start with some vocabulary. Systems of linear inequalities. A set of two or more linear inequalities containing two or more variables. In the previous section, we dealt with one linear inequality. Now we can have two or more. A solution of a system of linear inequalities consists of all ordered pairs that satisfy all the linear inequalities in the system. So let's practice identifying solutions of systems of linear inequalities. So just like in previous units, we have our x and y. So we substitute y in, so 1 is less than negative 2 plus 4. And, well, 1 is less than 2, so that works. And now we substitute it into the other one. So we have 1 is less than or equal to 2 plus 1. And 1 is in fact less than or equal to 3. So yes, it satisfies both conditions. Take a moment and pause the video and try B. When you return to the video, the answer will be revealed below. So we substitute in our x and y, and when we substitute it into the first equation, we end up with something that's not a true statement. So it doesn't satisfy the first one. It does satisfy the second one, but that doesn't mean that it works for both, so the answer is no. It has to work for all of your equations. It can't just work for one and not another. So now let's look at graphing. Before, we talked about having one line and anywhere in the shaded region is a solution. Well, now you have more than one inequality. So when you shade, it's where it's shaded both times or for both inequalities. So for example, if we look at 1a over here, so you have your dashed line here, and you shade below that one, and then you have the blue solid line here, and you shaded below that one. So the area that's been shaded twice in this case is your solution set. Any point you pick in this area is going to be a solution. Let's look at 1b. Notice how you shaded above the red and then below the blue dashed line here. Well, where it's been shaded twice, that's where your solution set is. However, if you were to pick any number that's way up here, or one that's down in the blue down here, that would be not a solution. It doesn't satisfy both the inequalities. Let's practice. So when solving systems of linear inequalities, you simply graph each inequality. My suggestion is graph one first. So when you graph one, you graph all of it. It's dashed or solid line and shade. Then do the other one. So let's look at our first inequality here. We want to get y by itself so that way we can actually graph what we're looking for. So I'm going to rewrite it down below. And we want to subtract 8x from both sides because we want to get y by itself. So now we have 4y is less than or equal to negative 8x plus 12. And now we can divide both sides by 4. Remember, you divide the entire side by 4. So we're left with y is less than or equal to negative 2x plus 3. So now we're going to graph the boundary line, which is going to be a solid line. And then we're going to shade below because y is smaller. So now that the first inequality is completely graphed, we can now graph the second. So the second one's going to be in red. So we have a dashed boundary line, and then we shade above since y is greater. Now it says give two ordered pairs that are solutions and two that are not. Well, if we look, anytime you have a shaded region where it satisfies every single inequality, you're going to have solutions there. So you can pick any 2 points in here, and those are all going to be solutions. It doesn't, I could pick in the middle somewhere here like this. Anything in this double shaded region is going to be a solution. So we can pick -2, 3. Or maybe we can pick -5, -2. Both of these are solutions. They fall in this double shaded region. If we want to give two ordered pairs that are not solutions, well, we can pick 4, -3. Or maybe we can pick 1, 6. Basically, anything not in the double shaded region is not a solution. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. So the first one is in blue here, and the second one is in red. So whenever you see y is greater than, or y is greater than or equal to, or less than or equal to, it's going to be that horizontal line. If you had an x instead of a y, it would have been a vertical line. So these are just possible solutions. You could have had different ones. And same with the ones that are not solutions. Anything that's not in the double shaded region is not a solution. So you could have had any of those possibilities. And there's infinite correct statements for both. What happens when we start trying to graph systems with parallel boundary lines? So we're going to graph each system of linear inequalities. So take a moment and graph both of these inequalities. Notice how after graphing both inequalities, there's no overlapping shaded section. There's no section that satisfies both inequalities. So therefore, there's no solution. Try this next one. So graph both inequalities. So in this case, the solution is going to be in the middle between the two parallel lines, because one was shaded below and one was shaded above. So between them is going to be the solution set. Let's try this one. Graph both inequalities. So notice how in this one, both inequalities were shaded below, which means that double shaded region here would be the solution set. So any points in this double shaded region will be a solution. Keep in mind, if you had 3 inequalities, the solution set would be the area that has all 3 areas shaded. Caution: an ordered pair solution of the system need not have whole numbers, but answers to many application problems may be restricted to whole numbers. So let's look at a business application. A surf shop makes the profits given in the table. The shop owner sells at least 10 surfboards and at least 20 wakeboards per month. He wants to earn at least $2,000 a month. Show and describe all possible combinations of surfboards and wakeboards that the store owner needs to sell to meet his goals. List 2 possible combinations. So we need 2 inequalities for one for our wakeboards and one for our surfboards. We're then going to need a third inequality that deals with the monetary amount. So let's start with writing an inequality for the surfboards. He sells at least 10 surfboards. So x must be greater than or equal to 10. And now let's write one for the wakeboards. He sells at least 20 wakeboards. So y has to be greater than or equal to 20. And finally, we have the inequality that deals with the monetary amount. So it's $150 for the surfboards plus 100 for the wakeboards, and whatever we sell we want to make at least $2,000. So now that you have your three inequalities, you can graph them. And when you do, it should look like this. 1525 is one possible solution, and 2520 is another. So like 15 surfboards and 25 wakeboards, for example. Now, you can't sell 15.5 surfboards and then 25 wakeboards. This is where that caution kind of comes into play. You have to sell a whole number of boards, no matter which way you're going. So any solution in the area that's been shaded 3 times would be a solution. Anything that's not in this 3 times shaded area is not a solution to this problem. And that, folks, ends our lesson on solving systems of linear inequalities.